is important to read the problem and not make up your own conic. Okay, the problem will tell you what conic is involved. So this one's semi-elliptical. So that's going to mean half of an ellipse. Like a semicircle is half a circle. A semi-ellipse is going to be half an ellipse. So here's the ground. Let's say we're looking at a house, and it says we have an arched doorway that's in the shape of an ellipse. It tells us it is 10 feet wide, so from here to here is 10, and it is 8 feet tall. Now remember, we have the rest of the ellipse down here, so even though we just have this part of it, we're still writing an equation for the whole ellipse. Okay, we're not writing an equation necessarily for half an ellipse, we're just writing the equation for the entire ellipse. It's important that we know which one's x and which one's, or whether it's horizontal or vertical. We do know that that's going to be the center. You can make your center whatever values you want. My suggestion would be 0, 0, because that's going to be the easiest. That's what I would do. Not all the problems are like that, but this particular one is. There's not a specific place we need it to be. So we know it's going to be x squared over something plus y squared over something equals 1. Because for ellipses, the x squared is first, the a squared is going to be the bigger number. So now we just have to decide if the bigger number is going to go under the x or the y. Now this is where this one can be kind of tricky because you see the 8 and the 10, and your first thought is, okay, well the 10 is bigger than the 8. And that's true, but the 10 is the entire distance, and the 8 is only half the distance. This down here is also 8. So this particular ellipse is going to be a vertical ellipse because 8 is the distance from the center up to the vertice or covertice. Then we also have this distance right here, which is 5. So that's why it's important to know that A, B, and C. A is the distance from the center to the vertex. B is the distance from the center to the covertex. And for ellipses, the vertex is always the longer distance from the center. So 8 is going to be our A distance, and 5 is going to be the B distance. So because the up and down is the bigger number, the 8 squared goes under the y, the 5 squared goes under the x. And there's your equation. So that one again can be kind of tricky because it only gives you the information for half of it, but the length given is the entire length. The height given is only part of the distance of the whole ellipse. All right, then the second equation, how high is the doorway 2 feet from the center? Okay, so now we're back just looking at this top half. So here's the center. Again, you could have made that center whatever you wanted. Doesn't matter. If you make it something other than 0, 0, it's just a little bit harder to do the next part. We want to know how high is it when we go 2 feet from the center. Whether we go left or right, it doesn't matter. Because here it's 8 feet. After that, it's going to be the same distance that you get from the center. The height's going to be the same, all the way down to 0. So we want to know how high is it 2 feet. So again, it doesn't matter if we go left or right. If we go 2 feet from the center, what is the height? So right there, we know that this is the x. X goes left and right. Y goes up and down. So we want to know what is the y value when x is 2. That's what that's asking. So we plug in 2. 2 squared over 25 plus y squared over 64 equals 1. That would be the work I would expect to see. Okay, you plugging in, knowing where to plug the 2 in. Or if you put 4 instead of 2 squared, that'd be fine. But this is the work I would expect to see, okay, for that second part. After that, you can do the rest of it as much in your calculator if you want. Now I'm going to show you how to do that in case you don't know what to do from there. So this is just a number, 2 squared over 25, whatever number that is. So we want to bring it to the other side. So you end up with y squared over 64 equals 1 minus 4 over 25. So again, all this can be done in your calculator. Then you multiply both sides by 64. And you get y squared equals whatever that number is. then you take the square root. Now, square root's plus or minus, but we're looking for a height. A height can't be negative, so all we care about is the positive value. So your answer would be 7.332, and we're in feet. And hopefully that makes sense. If the highest point is 8, your answer for anything, whether we're 1.5 feet, 2 feet, 3 feet, 4 feet, however far away we are, will be less than 8. We know it's going to be less than 8. Questions? Okay. So again, this you can get by looking at the picture. As far as work, showing your work for credit, I would just expect to see you plugging that in. After that, you can do it all in your calculator. If you want to show the steps, you can, but you do not need to. All right, this next one. Bam Bam is in a tree that's 14 meters above the ground. He swings to the same height in another tree. Tells you when he reaches his lowest point and what the height is. So this is going to have an x and a y where we're going to have time and distance. And we want to assume his flight is parabolic. Okay, I'm not sure if that's written on your notes or not, but we're going to assume his path is parabolic. On the test, we would tell you what the path would be. You don't ever have to guess, okay? It will, somewhere in the problem, it'll tell you what the conic is. So the first question, how long after leaving the first tree does Bam Bam reach the second tree? That one you can do just by reading, but I'm going to start drawing the picture down here. So this picture, it says Bam Bam starts right here, 14 feet off the ground. Okay, so he's 14 feet off the ground. Then he swings to another tree where he is still 14 feet off the ground. There's the ground. It tells us that after 1 second, point 5 feet off the ground. Okay, this is 1 second. This would be 0 seconds and 0 height right here. He started 14 feet, so he hadn't gone anywhere. No time had passed. He was 14 feet in the air. After 1 second, he was at the low point. The time it took to get back up to the same height is going to be another 1 second, so this one's 2 seconds. So we could answer that one without even doing anything. Some of you could answer that even without drawing the picture. If it took him 10 seconds to get to the low, then it would be 20 seconds. If it had taken him 1.5 seconds to get to the low point, then to get back up to the same height, it would have been 3 seconds. Whatever it is, 1 second to the low point, and then another second to get back here. So this would be 2 seconds if we're looking at our picture. Now, we want to write an equation that relates Bam Bam's height as a function of time. But first, we just want to write our parabola in our conic form that we know. It's a parabola that faces up, so that's going to be y minus k equals a times x minus h squared. That's what we've been doing. We know a is positive because that parabola we drew is facing up, so it's going to be a y equals x squared. Now, this is the vertex. The vertex is hk. The time down here is going to be our x value, and you can use whatever letters you want. I'm going to say down here is my x, which is time. This is my y, which is the height. Because it doesn't tell you what letters to use, you can use whatever letters you want. If you want to use T and H, you can. I'm going to use X and Y because it doesn't tell me, and I like those letters. So we know our HK right here is 1, 5. So that takes care of the H and the K. But in order for me to find that A value, I also need a point on the parabola. I have 2 other points on the parabola. Okay, here's the parabola. I have this original point. After 0 time, he was 14 feet up. Or I have this one. After 2 seconds, he was 14 feet up. Doesn't matter which one you use. You can use either point. It's going to get you the same answer if you do it right. So I'm going to use this and this. This is my XY. This is my HK. Even though it's HK, so you can't use XY in place of HK. So I'm going to plug all those numbers in. When I do that, then I'm only left with one variable, because I can solve if I only have one variable. So y is 14, k is 5, a is what I'm looking for, x is 0, h is 1 squared. So I get 9 equals a times negative squared. So a is equal to 9. So now I have all the parts to write my equation of a parabola. Y minus 5 equals 9 times x minus 1 squared. But it tells me to write the height as a function of time. So if I do that as a function, it's f of x is function notation, and I just need to bring that 5 over. So it's 9 x minus 1 squared plus 5. There's a function. That goes back a couple units, remembering how to write something as a function. That first version is just standard form of a conic, but function notation means we need to have y equals. If you just left it y equals, that'd be okay, because we don't have to write it in function notation, but just know that's a lot of the times what it will look like. All right, so the question there, what is the height 1.5 seconds after leaving the first tree? So this one's a non-calculator problem. All of this stuff we can do without a calculator. So we want to know what is the height after 1.5 seconds. So we're going to plug in 1.5 for x. So 9 times 1.5 squared plus 5. Whoops. Minus 1. Yes.
Do you mind if the student just sits in the corner and works by it?
Sure, not at all.
Okay, great, thank you.
1.5 minus 1, so 9 times 0.5 squared plus 5. All I'm doing is plugging in and solving. So I don't like decimals. I'm going to change that to 1/2 squared. 1/2 squared is 1/4. So 9 times 1/4 plus 5 is 9 over 4 plus 5. 9 over 4 plus 20 over 4 is 29 over 4, and we are in meters. Again, 0.5 squared is what? 0.25. 0.25 is the same as 1/4. 9 times 0.25. If you like decimals better than fractions, use decimals. But this would be a non-calculator problem. I think it's a lot easier to square 1/2 than it is 0.5. And it's a lot easier to multiply 9 times 1/4 than 9 times 0.25. But both of them are going to get you the same answer. It's just going to be decimal versus fraction. But they're exactly the same. Now, I added this question to it because just like everything, you can be given x and find y, given y and find x. So if I said, gave you the y value and you had to find the x, you just plug in 7.25 equals 9 times x minus 1 squared plus 5. Still a non-calculator problem. If I change that to 7, then now it might be a calculator problem. Okay, just depends on the number, but this particular number we can do without a calculator. So I subtract 5 and get 2.25 equals 9 times x minus 1 squared. Now remember, we're given the y value. This is 14 feet. This is 5 feet. So here's 7.25 somewhere in there. So we're going to be at 7.25 on the way down, and we're going to be at 7.25 on the way up. So there's going to be 2 answers. Now, I don't like decimals. So 2 1/4 is the same as 9/4. So I'm going to make that 9/4 equals 9 times x minus 1 squared, since I don't have a calculator to do this problem. And then I'm going to divide by 9. 9/4 divided by 9. I can't divide fractions, so 9/4 times 1/9 is equal to 1/4. 1/4 equals x minus 1 squared. Take the square root, plus or minus. This is where my 2 answers are going to come into play. Square root of 1 is 1, square root of 4 is 2. So we have plus or minus 1/2 equals x minus 1. Add 1, we end up with 1/2 plus 1, which equals 1.5 seconds. we have negative 1/2 plus 1, which is 0.5 seconds. So there are your two answers. So you can be given x and find y, one value, or be given y and find x. Typically, there's two values. Unless one of them had been on the negative side, then we wouldn't have counted that answer. All depends on what the numbers are. If this had been a calculator problem, up here at this point, we could have done y1, y2, plugged it in, found the intersect for both of those, and you had your answer. Okay, either way will work. Just depends if you have a calculator or not. And your test next week will be calculator and non-calculator. Okay, it'll be a little bit of both, I think. If that changes, I'll let you know. All right, we want to find the equation of an outside border of a track, and it's elliptical track. Again, that elliptical word is important. Don't just make up your own conic. Don't just think, oh, it's a track, so I'm going to make it a circle. Okay, it tells you it's an ellipse. It even gives you an equation of an ellipse right there, and it says the field can be described by the equation below. All right, so we have a field. This, since the bigger number's under the y, we know that field, okay, here's the field. We want to know there's a track around the field. We want to know what that entire, so we want to know the equation of that red ellipse that I just drew. We know what this is and what this is because of this equation right here. Since a squared is 9, we know a is 3, b squared is 4, we know b is 2. The reason we knew that is because the bigger number was under the y. The bigger number, ellipses, a squared is the bigger number. And since it's under the y moves up and down. That's why the 3 went up and down and the 2 went side to side. Now this track, so think about any track you've seen, okay? This is the area in the middle. This track, it tells us, is 12 feet wide. So this is 12 and this is 12, just the track part, not the inside field. But we want to know the equation of that big ellipse. So just like before, we know it's going to be x squared, y squared. If you want your center to be something else, that's fine. It doesn't matter what the center is, but typically on an ellipse, unless it tells you the center is something else, it's going to be 0, 0. So here is my new y. From the center all the way out is my a value. So 3 and 12 is 15. So now that length is 15. So 15 squared, 225. From the center all the way to the outside of the track is 2 plus 12, which is 14. 14 squared, 196. So there's your equation of the ellipse. And that's it. Questions? All right, Pebble owns a satellite dish that is in the shape of a parabola. The dish is 16 feet across and 8 feet deep. So a long time ago, way before, like when I was little, in order to get like a lot of TV channels, if you lived out in the country, you had to have this big, huge white thing in your backyard in order to get any channels. Y'all probably never even seen that, or it's like in some museum or something now. I don't know. Okay, but that's how you got TV channels at your house if you lived out in the country. Okay, so it's probably a little bit of an outdated problem, but these are the ones that we have. So it wants to know what distance from the center of the dish should Pebbles place the receiver to achieve this intensity of sound. So on these problems, anytime it's something parabolic, okay, shape of a parabola, and it talks about the greatest intensity of sound waves or radio waves, any kind of problem like that, what you're really looking for is the focus. That's going to be the point where any kind of receiver is placed. Sometimes you'll see those like DirecTV or Dish, those little gray ones, and there's a little thing sticking out of it. That little thing sticking out of it is the focus. Okay? It doesn't tell us which way the parabola faces, so you can face it whichever way you want. The easiest is to make the parabola going up, because that's just the y equals x squared. So that's a y minus k equals a times x minus h squared. You can make it up, down, left, or right. It doesn't matter because it doesn't say. And you'll get the same answer no matter where you face it. So what we want to know is this right here, which is our p-value. We want to know how far away from the vertex should that receiver be placed. What we know is the distance across is 16, and we know this entire height of the whole dish is 8. That does not mean our answer is 8, and we're done. Okay, we got to figure out what p is. All we know is we have this big dish-looking thing that's in the shape of a parabola, and we know how tall it is, and how wide it is. All right, so this vertex right here, this would be the vertex. We can make that vertex. We can make this point, or this point. We can pick what point we want that to be because it's just placed somewhere. I'm going to say the vertex is 0, 0. You can say this is 0, 0, this is 0, 0. It doesn't matter. Okay, because we're not looking for anything. We're just writing an equation and finding a p-value. So if we know this whole thing is 16, that means this distance is 8 and that distance is 8. So in order to find our a value, and the whole reason we have to find a is because a equals 1 over 4p, and p is what we're looking for. So that's why we have to write this equation, because we need to find a in order to find p. All right, so y, k, x, and h, that's what we need. We already have our hk. It's 0, 0. Then we just have to pick one of these points to figure out what it is. Well, if this is 0, 0, and I go right 8 and up 8, this is the point 8, 8. Or you could have said negative 8, 8. You could have said this is 0, 0, then your xy would be 0, 0, and this point down here would be 8, negative 8. Any combination of those will work. All right, so now I just plug everything in. This is my x and my y, and I solve for a. So y is equal to 8 minus k is 0. A is what we're looking for. X is 8. H is 0 squared. 8 minus a times 8 squared, which is 64. Divide by 64. A is equal to 1/8. That's not your answer, that's a. We need to find p. So 1/8 equals 1 over 4p. Some of you can look at that and know what the answer is immediately. If not, cross multiply. 4p equals 8. Divide by 4. And p equals 2. And we're in feet. So there's your answer. Anytime it asks for some kind of receiver or greatest intensity of radio waves, sound waves, whatever it is, you always have to find p. And the only way to find p is to find a. All right, this last one is a calculator problem. So you will need your calculator for this one. And I believe on your notes it says do not round. So we're just going to write the whole number. I think that was added. If you printed your notes, it says do not round. So that just means we're going to write the whole number. It means it's not going to be, it's going to be a big number, but there's not going to be a bunch of decimals out to the side. All right, so I drew this picture for you on here. So it says Mercury has an elliptical orbit, and it's anywhere from 69.86 meters from the sun versus 46.04 meters from the sun, okay? So if Mercury's over here, there's the sun, it's 69.86. When Mercury gets over here, it's 46.04 kilometers from the sun. The sun is a focus. This is where knowing A, B, and C is going to be very, very important, okay? If you had drawn this vertically, it would have been okay. Okay, typically, I would think when you would draw this, you would draw it horizontally, but if you drew it vertically, it wouldn't matter. Your numbers would be flip-flop, but that would be okay. I would just look at your picture to figure out whether you drew a vertical or horizontal ellipse. All right, so we know it's going to be x squared over something, y squared over something equals 1. Okay, that we know for sure because it's an ellipse. We just got to figure out where to put the a squared and the b squared and what a squared and b squared are. All right, so first, if we were to cut this in half right here, there's the center. Again, if you wanted your HK to be something other than 0, 0, you could have done that. All right, so we need to know our a value. A value is from here to here is a, or here to here is a. A is not given. We have to figure out what it is. So we know the whole thing, right? We know from here to here is 69.86. We know from here to here is 4604. So if we add all those two numbers together and divide by 2, we're going to figure out what A is. Okay, so 69.86 plus 46.04 divided by 2 gives you your A value, which is, you should get 57.95. And then a squared, when you square that, you get 3,358.2025. So when it says do not round, that means just write all 4 numbers. Okay, so again, we knew the whole distance. The whole distance is 2, it's the major axis. The major axis was 2a. The reason we knew that was the major axis is because the focus was on it. The focus is always on the major axis for an ellipse. Now, the only way to get b squared, we don't know how high up and down the orbit goes, but we know a focus. So here to here is going to be c. Another number we are not given. We don't know it, but if we know the distance from the center to the vertex, and then we know this, that's just a matter of subtracting. So we know 57.95 minus 4604 is going to leave us with our C value. This whole thing is 57.95. If we take away 4604, that leaves us with C, which you should get 11.91. Now we can find B. Our equation is c squared equals a squared minus b squared. If we bring the b over to the left, it becomes positive, a squared minus c squared. So we take that 3,358 number, subtract it from 11.91 squared, and you're left with your b squared. All that matters is what b squared is. Doesn't matter what b is. And then you just put it under y, and you get 3,216.3544. And there's your equation. Also, to pass you out a worksheet, but this tells you which ones to use a calculator on so that you have an idea of what it would be like the testing quiz. I'm going to leave this here. But number 2 did not print very well. So there is a picture. You can take a picture of it, whatever you want, or look at it. But number 2 on your worksheet did not print very well. So there is